Right now, somewhere over the Atlantic, a standard-looking wide-body airliner is just flying along at 500 miles per hour.
It's a normal flight, right?
Exactly. But instead of carrying hundreds of vacationers eating pretzels and, complaining about the legroom, its skeleton is actually packed with 245,000 pounds of highly flammable jet fuel.
Wow.
Yeah, and out the back, it's using robotic computer vision to pump a literal river of that fuel into a stealth fighter mid-flight, entirely in the dark.
It's just an incredible image, isn't it? I mean, in a world of information overload where defense discussions are constantly dominated by flashy next-generation fighter jets.
Right, hypersonic weapons and all
Yeah,
that.
hypersonic conceptual weapons. The real backbone of modern global military reach is often just hiding in plain sight. Understanding this specific aircraft we're looking at today is the actual key to understanding Allied interoperability.
Okay, let's unpack this. Because we've got a stack of official technical and strategic documentation straight from Airbus Defense, and our mission for this deep dive is to understand the A330 MRTT.
Which stands for Multi-Role Tanker Transport.
Yes. We are also going to look at its brand new evolution, the MRTT Plus. What we are really exploring is how a standard commercial passenger plane is transformed into a highly advanced military asset.
And it's dominating the space, absolutely.
Oh, completely. The documents show it currently holds a 90% market share outside the US.
And that staggering market dominance, it doesn't just happen by accident.
No, I imagine not.
Right, it comes from a really fascinating metamorphosis, one that physically takes place across two completely different countries.
Oh, really?
Yeah, so the life cycle of this machine begins in Toulouse, France. It is initially assembled as a standard A330 200-passenger airframe.
Wait, so it rolls down the exact same assembly line right alongside the commercial jets heading to major global airlines?
Exactly.
So it literally starts as the flying bus you and I take to go overseas?
It does, yeah.
I bet.
But instead of being fitted with, in-flight entertainment screens and overhead bins.
The fun stuff.
Right. Airbus flies this raw airframe over to a highly specialized facility in Getafe, Spain.
Got it.
That is where the commercial illusion is stripped away
Yeah.
and the military conversion actually happens.
I was reading through the engineering specs for the Getafe process, and they don't just bolt on some radios.
Oh, definitely not.
They have to open up the airframe and integrate military-grade avionics, secure communication nodes, and massive structural reinforcements.
Because if you think about it, hanging a giant metal fuel pipe off the tail of an airplane creates an immense amount of aerodynamic drag.
And torsion, right. The physical stress on the tail section must just be incredible.
The structural fatigue is a massive engineering hurdle. Yeah. You are taking an airframe designed to carry humans smoothly through the sky.
Right.
And you are subjecting it to the turbulent wake of fighter jets flying mere feet away from its tail, all while transferring massive amounts of weight.
Wow.
But the most vital structural element isn't actually what they add, it's what was already there.
Right, the fuel capacity. The numbers in the Airbus documentation are just wild. The baseline fuel capacity of this aircraft is 111 tons.
Yeah, to put that in perspective for you listening, that is roughly 245,000 pounds of jet fuel.
Wait, how does an aircraft hold 111 tons of fuel without stuffing the cargo hold full of extra bulky gas tanks?
That's the big question.
Because if you have to fill the belly of the plane with external fuel bladders, you lose all your cargo space. You can't put anything else in there.
What's fascinating here is that this specific question highlights the absolute genius of using the A330 wide-body design as the foundation.
Okay.
The 111-ton fuel capacity is built right into the existing structure of the aircraft. It is housed primarily within the massive wings and what engineers call the center wing box.
The center wing box, is that just where the wings meet the fuselage?
Essentially, yes. It's the structural heart of the aircraft, like a massive reinforced aluminum vault that spans the width of the lower fuselage to connect the two wings.
Oh, I see.
Because the A330 was originally engineered as an ultra-long-haul commercial airliner, meant to fly over oceans for 15 hours at a time, it already possessed this cavernous internal fuel capacity.
Ah, so Airbus simply leverages that existing architecture.
Exactly. The result is that they leave the main cabin and the lower cargo decks completely free.
So the fuel is entirely hidden within the skeleton of the plane.
Yes, and that single design choice is what makes the multi-role part of the MRTT possible.
Okay, so that explains the architecture, how this giant structure inherently holds 245,000 pounds of fuel.
Right.
But obviously carrying the fuel is only half the battle. If we look at the core mission, delivering that liquid midair is an incredibly hostile physics problem.
The performance specifications here are critical. A According to the documentation, the MRTT can offload up to 70 tons of fuel.
Which is over 154,000 pounds, just to clarify.
Yes, a massive amount. It can offload that during a 1-hour loiter, and it can do this at a distance of 12,250 nautical miles away from its takeoff point.
Which means it flies over 1,000 miles out, hangs out in a holding pattern for an hour, acting as a gas station, dumps 70 tons of fuel, and then flies 1,000 miles back.
Exactly. And it utilizes 2 distinct delivery systems to achieve that, allowing it to service entirely different types of aircraft on the same mission.
Right, I saw that.
At the rear, it has the air-to-air refueling boom, which is a rigid, steerable, telescopic pipe. Then, under the wings, it utilizes pods equipped with a flexible hose and drogue system.
I always see those terms thrown around. Just to clarify the drogue system for you listening, think of it like a heavy-duty flexible hose that trails behind the wing.
Like a giant garden hose.
Yeah, and at the end of it is a basket that looks almost like a giant shuttlecock.
That's a good way to describe it.
The receiving fighter jet has a probe on its nose, and the pilot has to manually fly that probe into the basket.
Which requires immense pilot skill, especially in turbulent air.
I can only imagine.
The underwing drogue pods on the MRTT push fuel at about 1,300 kilograms per minute. But the boom system at the tail is a completely different beast.
The numbers on the boom system are genuinely terrifying.
They really are.
It transfers fuel at a maximum rate of 3,600 kilograms per minute.
Wow.
That is a ton of fuel every 16 seconds rushing through a pipe in the sky.
It's unbelievable.
And because it has both the drogue and the boom, the documents note it can refuel basically anything in the Allied arsenal. F-35s, Eurofighter Typhoons, massive B-52H bombers.
And even other A330 MRTTs.
Which sounds wild. Refueling another tanker might sound redundant.
It does, but tactically, it extends your global reach almost indefinitely.
Right.
The aircraft already boasts up to 18 hours of autonomy and an 8,700 nautical mile range. But I want to go back to that fuel transfer rate you mentioned.
The 3,600 kilograms per minute.
Yeah, that flow rate isn't just impressive, it's a massive physics challenge. When an aircraft suddenly loses thousands of pounds of mass from its rear section in a matter of minutes.
Oh, right. The center of gravity drastically shifts forward.
Exactly, because the tail suddenly gets lighter, so the nose wants to dive.
Yeah.
The flight computers have to constantly adjust the aircraft's trim in real time to keep the plane flying level.
All while a bomber is physically connected to it via a metal pipe, which is incredibly dangerous.
Beyond dangerous.
And for decades, the boom operator, the person steering that pipe, was literally laying on their stomach looking out a window at the back of the plane.
Yeah, just using a joystick to manually fly the boom into the receiver jet.
But the Airbus documentation reveals a massive technological leap that changes all of that.
It really does. The MRTT is the world's first tanker to feature certified automatic air-to-air refueling.
Also known as A3R, right?
Yes, A3R. It's been proven in service since 2022.
I had to read this section twice because it feels like science fiction.
Does sound like it.
The A3R system uses advanced computer vision technologies. It doesn't need a human to fly the boom anymore.
It fundamentally removes the manual input from the most dangerous part of the operation.
That is amazing.
The system uses a network of high-definition cameras and sensors to automatically detect the receiver aircraft.
Okay.
It calculates the closure rate, tracks the receptacle in real time, and engages the boom to make contact.
I mean, I equate that to parallel parking a semi-truck at 500 miles per hour. But how does a camera system track a fast-moving, dark gray stealth fighter jet in the middle of the night?
Or when you're flying directly into blinding sun glare above the clouds, frankly.
Exact.
It does it by analyzing pixels and contrast at speeds humans simply cannot match.
Oh.
The computer vision algorithms are trained to recognize the specific geometry of the receiving aircraft.
So it just filters out environmental interference like clouds or glare?
Completely. It calculates the relative motion between two objects moving at 500 miles per hour and makes micro adjustments to the boom's flight control surfaces instantaneously.
It's essentially introducing self-driving tech to the most stressful part of aviation.
That's a perfect analogy.
But why is this so critical? I mean, if human operators have been doing it successfully for 60 years, why spend millions developing an autonomous boom?
Because human operators suffer from fatigue.
Yeah.
In a prolonged combat scenario or a high-stress global deployment, you might have crews flying multiple sorties over 18-hour shifts.
Right, the exhaustion must be intense.
The cognitive load of manually flying a boom into an F-35 in bad weather is immense. A3R doesn't just look cool, it optimizes operations.
It enhances precision.
And drastically reduces the risk of a mid-air collision caused by human error.
Okay, so we've established the fuel is hidden in the internal wing box, and we've got a robotic computer vision boom delivering it automatically in the back. That answers how the exterior works. But since the belly is completely empty, I want to talk about what is happening inside the cabin.
The multi-role reality.
So what does this all mean? The documents break down the interior configurations, and it is just a logistical marvel.
It really is.
Let's start with troops. The MRTT can transport up to 300 passengers, and the text specifically emphasizes airline comfort.
Right, so we aren't talking about soldiers sitting on canvas benches strapped to the wall with their knees touching.
Yeah, exactly. This is a commercial airliner seating layout, which can even be configured for VIP transport.
And beneath those troops in the lower decks, you have the cargo holds, because the fuel isn't taking up that space.
Right, the wing box holds the fuel.
Exactly. So the MRTT can carry up to 45 tons of total payload, which includes 37 tons of pure cargo.
The specs mention it utilizes 2 lower deck compartments, forward and aft, and a rear bulk area.
Yep.
But what caught my eye is that it accommodates both military NATO pallets and civilian unit load devices, or ULDs.
That dual compatibility is a massive advantage.
Yeah.
ULDs are those contoured aluminum containers you see luggage being loaded into at a civilian airport.
Oh, right, the silver ones with the angled corner.
Exactly. Whereas NATO pallets are the heavy-duty wooden or aluminum platforms used for military airdrops and bulk supplies. Being able to seamlessly lock both systems into the cargo floor means you can land this aircraft at a commercial airport in Tokyo or a military airbase in Europe.
And the local ground crews already have the equipment to load and unload it instantly.
Yes, it speaks directly to that interoperability you mentioned earlier.
But here's the configuration that I think is the most impressive. Medevac. Medical evacuation.
Oh, it is arguably its most critical non-combat function.
The flexible cabin can be transformed into a flying hospital.
Literally.
And I'm not talking about just laying wounded soldiers across standard seats. They use a modular track system on the floor. Think of it like a giant Lego grid.
Right.
Where they can strip out the passenger seats and lock in intensive care units.
It's incredible.
It can be laid out with up to 40 stretchers, designated seats for 20 medical staff, and still have room for 100 passengers.
And those stretchers aren't just beds.
No,
they integrate directly into the aircraft's power and oxygen supplies, allowing the medical staff to provide continuous, critical care simultaneously with the transport of troops and cargo on the decks below.
Think about the efficiency of that for a second. If a nation is responding to a massive natural disaster or a crisis zone, they don't have to scramble 3 different planes.
Exactly.
You don't need a tanker to refuel the fighter escort, a heavy cargo plane to bring in the disaster relief supplies, and a dedicated hospital plane to bring the wounded out.
Yep.
You just send this one MRTT, it refuels the fighters on the way in, drops off the cargo, loads up the wounded, and flies home.
One flight crew, one asset to protect, which is exactly why 18 nations have adopted this platform.
It makes perfect sense.
The documentation lists operators like Australia, the UK, France, and the NATO multinational MRTT fleet.
Which is an incredible program, by the way.
It really is. Countries like Germany, the Netherlands, and Norway actually pool their resources to share a fleet of these aircraft.
That's fascinating.
It all comes down to proven reliability. The fleet currently has over 340,000 flight hours and has completed more than 310,000 air-to-air refueling contacts. It has been combat-proven in major operations since 2014.
But even a proven workhorse with a 90% market share eventually hits a ceiling.
Naturally.
Aviation technology moves incredibly fast, which brings us to the newest evolution in the source material, the A330 MRTT Plus.
The Plus variant is a fascinating study in how defense contractors modernize successful platforms without reinventing the wheel.
Right.
The original MRTT, with 91 total orders and 66 in operation, is based on an older generation A330.
Right, the A330-200.
Yes.
But the MRTT Plus is built on the A330-800 airframe, which is part of Airbus's newer A330neo family.
Exactly. And they've made some very targeted upgrades. They've swapped in Rolls-Royce Trent 7000 engines.
Okay.
They've optimized the wing aerodynamics, and they've added these new blended wingtip devices that curve upward.
Those aerodynamic tweaks and next-generation engines translate to one major major headline benefit and up to 8% lower fuel burn.
Which is massive.
The brochure also mentions reduced noise and lower CO2 and NOx emissions. NOx being nitrogen oxides, the pollutants created by high-temperature combustion.
Right.
Plus, the maximum takeoff weight, the MTOW, has been increased from 233 tons to 242 tons.
And the cabin is quieter and has more stowage.
So we are looking at 9 extra tons of lift capacity.
Yep.
Here's where it gets really interesting. I saw in the notes that the Royal Thai Air Force just ordered the MRTT Plus in September 2025.
They did, yeah.
But if the original MRTT is already dominating the market, why push so hard for this plus-sized upgrade now?
It's a fair question.
Because 8% lower fuel burn sounds great for a commercial airline trying to save a few bucks on a ticket, but does 8% really revolutionize a military operation?
If we connect this to the bigger picture, you have to look at the math of global logistics.
Okay.
An 8% fuel saving and a 9-ton increase in takeoff weight are not incremental upgrades.
They aren't.
No. Over the lifespan of a military asset, they are massive strategic multipliers.
Walk me through that math.
Think about it this way. These aircraft are designed to remain in service for 30 to 40 years.
That's a long time.
If a fleet of 10 MRTTs flies tens of thousands of hours over that lifespan, an 8% reduction in fuel burn equates to millions of pounds of jet fuel that you no longer have to consume.
Which means millions of pounds of fuel that you don't have to buy.
Exactly. But it's beyond the financial cost.
Oh, right.
In a theater of war, fuel doesn't just magically appear.
Right, you have to get it there.
It has to be refined, transported on vulnerable shipping vessels, driven in vulnerable truck convoys.
And stored at forward operating bases.
Every gallon of fuel you save in the air is a gallon you don't have to risk human lives to transport on the ground.
Wow. So as global defense budgets tighten and supply chains become prime targets, efficiency is a tactical advantage.
It is. Burning less fuel means your fragile supply lines are physically less stressed.
Precisely. And let's look at those emission and noise reduction.
Right. The CO2 and NOx.
Lower emissions generally correlate to a smaller thermal footprint. And a quieter engine is harder to detect acoustically. In a contested environment, lowering your signature is always beneficial.
Oh, absolutely. And that extra 9 tons of takeoff weight,
Yeah.
it gives combat commanders a wider envelope of options. That is 9 extra tons of medical supplies for an earthquake zone.
Or 9 extra tons of fuel you can offload to fighter jets protecting a carrier strike group.
Exactly. It's about wringing every single drop of utility out of the physics of the airframe.
So as we pull all of these threads together, let's look at the incredible journey we've mapped out today.
It's been a ride.
We started with a standard civilian passenger jet rolling out of a factory in Toulouse, France.
Yep.
We watched it fly to Getafe to have its interior stripped and its skeleton reinforced, turning that massive center wing box into a 111-ton hidden fuel tank.
Just incredible engineering.
We explored the physics of how it uses stereoscopic computer vision to autonomously plug a boom into stealth fighters at hundreds of miles per hour without throwing off its center of gravity.
All automatically.
And we saw how the empty cabin above allows it to simultaneously carry 300 troops, or serve as a modular 40-bed flying hospital, all while hauling NATO cargo pallets in the belly.
It is the ultimate logistical force multiplier, honestly, capable of crossing 8,700 nautical miles and staying airborne for 18 straight hours.
It really makes you think.
It does.
The next time you are sitting on a wide-body passenger jet, squeezed into your seat, waiting for takeoff and hoping the Wi-Fi works,
Right.
take a moment to look around. Imagine that exact same physical volume of space serving as an airborne gas station, an intensive care trauma ward, and a heavy military freighter, all at the exact same time, projecting power somewhere else in the world.
It's a brilliant way to visualize it. But before we wrap this up, there is one final detail buried in the Airbus source material that completely changes the calculus of how we should view this aircraft moving forward.
Oh, what did you find?
The documentation outlines Airbus's plan to leverage their multi-domain experience to turn the MRTT into a battlefield communications, surveillance, C2, and intelligence node.
Wait, C2, command and control.
Yes. They aren't just upgrading the engines and the boom.
Right.
They are planning to put the actual brains of a military operation inside the tanker.
So it's not just moving fuel and troops, it's moving the data.
Think about the implications for the future of aerial warfare. Historically, a tanker is a logistics node.
Yeah, a flying gas station.
It's incredibly valuable, but its value is entirely in its fuel. If the MRTT is already the flying gas station, the hospital, and the cargo ship,
Yeah.
what happens when you also make it the central communication hub and the surveillance eyes of the entire battlefield?
Oh, wow. If it is emitting massive amounts of data link signals and directing the battle, it goes from being a support vehicle in the background to being the absolute most critical, high-priority target in the sky.
Exactly. Which leaves us with a critical question to ponder.
Okay.
How does turning a massive, highly visible tanker into a primary intelligence target change the way Allied forces will have to protect it?
That is a great point.
If the MRTT Plus is holding the fuel, the troops, and the data all at once, it becomes the ultimate single point of failure and the ultimate strategic prize for an adversary.
You solve all your logistics problems by putting everything into one incredibly efficient airframe, but in doing so, you create the biggest target on the board.
Exactly.
That is a wild thought to leave off on.
Okay.
We hope you've enjoyed this deep dive into the A330 MRTT and the MRTT Plus. Thank you for joining us today, and remember, keep questioning the complex systems running the world around you, especially the ones hiding in plain sight.